All right, and finally, what we're going to do now is let's assess the internal loads. So the first one, let's see axial load. Ooh, as you can see here, the structure is under a lot of compressive forces. So on the beam here, you have a lot of compression, so around minus 44 kilonewtons. It's around 4 tons, okay, of load under compression. This is interesting just because of the thermal effect. Also, here on the beam, where you had the triangular load, this beam is also subjected to around 40 kilonewtons, which is quite a lot. So whenever we assess in a structure, if you're considering the design of beams and if you do not take account the actual effects, your beams might prematurely fail. So this is an important thing. And as you can see, look how interesting. The columns actually, they are receiving less load than the beams whenever we apply these boundary conditions, which is quite interesting, huh? Uh, all right, and let's see now shear forces. Shear forces here, they're quite small. I would say here in this column here, we have a lot of it, around 4 tons too, and this one as well. And you can see the reactions of the frame, you have a lot of bending moment. As you can see, this situation had created around 120 kilonewtons per meter here, which is a lot of bending moment, and here as well. Okay. And finally, let's see the deformation of it. Let's see the horizontal deformation first. X direction. So it's not deforming a lot. This is remembering it's in millimeters. So the deformation here is around 0.2 millimeters, which is quite low because of this frame here. This frame is very strong. This column here, because we said it's a rigid member, which the reality it's not, because it's like a 4-meter column which has only 60 centimeters diameter. We know that this member is deforming, but because of this property, the whole frame is very stiff. Okay. So let's change a few things so you guys can actually see the results whenever we change some of the circumstances. Oh, I forgot measuring, but let's see how much it deformed here. So this frame here, because of the spring, it deforms around 9 millimeters, which is a lot, significantly a lot. So whenever we are assessing this settlements of structures, if you don't define very well the spring of your support conditions to measure how much will it deform, you can have a lot of damage in your structure. Okay, and here the imposed displacement also created very stiff boundary conditions when we have that frame here, that column which is very strong. Let's just change a few things now. The first thing that I'd like to change is the stiffness of this member. Let's go back into the frame and let's just say it's a flexible member. All right, so let's just see now the results. As you can see, it changed a lot. All right, this is the bending moments. Let's just see the deformation. Okay, the deformation now it's quite a lot here. As you can see here, let's see horizontal deformation first. So the structure deformed to the left around 2 millimeters. All right, and the spring here, you had more deformation. You have around 18. So interesting, huh? Because you remove the rigid frame, the whole deformation of the structure was increased. All right, very interesting, huh? Also, let's just remove this. Let's remove this supporting conditions. Let's go back and let's say it's also fixed. All right, and let's just remove this prescribed displacement. Okay, and here on the other side too, let's just remove this prescribed displacement as well. Okay, it was also fixed in the three directions. Now let's see the results again. Whoa, it changed a lot, right? As you can see, the bending moments, they decreased so much. So you had a severely decrease in bending moment because the deformation that you impose on the structure creates a lot of internal stresses, all right? Especially when you have it in a term structure as this one. Very interesting results, huh? Let's see in terms of displacement. Oh, actually, let's see in terms of actual load. Okay, So the actual load changed a lot too. We had like around 44 here kilonewtons, and now we have lower than 4. So it diminishes a lot. Let's see the bending moments as well. The bending moments here, they're quite okay, I guess, I would say. And here was around 120, and now it's 11, 12. So the imposed displacement in this situation here for this frame was more important than the thermal load, right? So this class here so far, I think it was quite interesting. You can play very different scenarios here in your structure if you like. You can also apply different loads at the same time. For example, here, let's change this. Let's increase a lot. Let's say it was we had a fire. So we assessed the structure and the temperatures rose around 250, which is a lot. And let's also pretend that the roof had load. Let's consider the roof had a load of 4 kilonewtons. We can use the one that we had previously, all right? So this is a combination of different variables, all right? And let's pretend that this bin was also under fire. All right, let's see now the differences. Okay, a lot of different results. So as you can see here, the flexural moments in the columns were excessive, all right? So the fire within the structure actually changed a lot the internal stresses. Let's see bending. Oh, look how much compression load this is. And let's see the deformation as well. Deformation was quite significant here too. Oh, 50 millimeters. All right. So yeah, so I hope you're liking so far this series of videos. I will conclude this frame with you because I think it was quite interesting. As you can see, the potential of this software are quite interesting. So we have assessed a beam and a 2 bay frame with all these variables. I'll just like delete this one so we can do a truss.